Hello friends, welcome to my channel. In today's video we are going to rotate the servo motor based on the direction of movement of obstacle in front of this ultrasonic sensor, and with each centimeter increment or decrement in the distance the servo rotates by 6 degree, right, like I have shown in the demonstration. Now let us start making the circuit connection. So first of all we will place the ultrasonic sensor on the breadboard, and the rightmost pin is the GND and the leftmost pin is the VCC. So connect all the 4 wires corresponding to all the 4 pins. So red wire will be connected to VCC and this brown wire will be connected to ground. Like this. So connect the red wire into the 5 volt of the Arduino Uno. So this is the 5 volt pin, and brown wire will be connected to ground. And these two wires will be used for echo and trig. So connect these two wires on the digital pins like pin number 7 and pin number 6. Now let us connect the servo motor. So this purple wire will be connected to the signal wire. So this yellow wire corresponding to the signal wire of the servo motor, and this red wire will be connected to the middle pin, and the brown wire will be connected to the ground. So connect this signal wire of the servo motor to the digital pin like pin number 5, and this red wire will be connected to another 5 volt of the Arduino Uno, which you can see here. So this is the 5 volt pin, and this brown wire will be connected to the ground. So this is the ground pin of the Arduino Uno. So this is the complete circuit connections of the project. And you may face one problem with the servo motor, and that problem is the jittering motion of the servo, because sometimes the Arduino's 5 volt pin cannot provide sufficient current to the servo to work it properly, because it has a gear inside it, right? So it requires a quite more power to work properly. So in that case you need to require external battery supply to power the servo motor, right? And you also need a LM7805 voltage regulator IC, because this battery is a 7.4 volt battery. So this IC step down the voltage from 7.4 volt to 5 volt, because the rated voltage for the servo is 5 volt. So we will connect the battery supply to the IC. So this blue wire is a positive terminal of the battery, so connect it to the left leg of the IC, and this black wire is the negative terminal, so connect it to the middle pin of the IC. Now take the supply pins or the supply wires of the servo from the Arduino Uno and connect it to the 7805 IC. So this the red wire will be connected to the right leg, which is a positive terminal of the IC, and this brown wire is a negative terminal, so connected to the middle pin of the IC, and connect these two wires as usual to the negative and positive terminal of the servo motor. Now we need one more jumper wire, because we also need to common ground between the Arduino and the battery, right, to work properly. So this black wire will be acting as a common ground between the IC and the Arduino Uno. So connect another end to the ground of the Arduino Uno. Now this is a complete circuit diagram of the project. So let me know in the comments whether you were already familiar with the jittering problem of the servo motor and how did you find the solution of that problem. And now let us move on to the program of this project. Now let us understand the logic of the program for this project. So we are defining two pins, trig and echo, for the ultrasonic sensor, and one servo object called myServo. And I have defined also two variables, duration and the distance. And I will start the servo motor from 0 degree angle. And as I have already told you in the starting that I will move the object from 0 to 30 centimeter distance, because it will be out of the field of view of the camera. You can change the distance according to your need. And in the setup function I am defining trig as output and echo pin as the input, and I have attached the servo motor to the pin number 8. So in the get distance function we are calculating the distance traveled by the object in front of ultrasonic sensor. Now you might think that why we are writing low signal two times on the trig pin. So let's understand this. So this first line is to ensure that the trig pin starts from a clear low state before sending a new pulse, because some of the ultrasonic sensor may hold a residual high signal from a previous loop, right? So to clear that high signal from a previous loop, we are writing low signal, okay? And after some delay, we are again writing high signal on the trig pin. So in this line, we are initiating the sending of ultrasonic waves. And after further delay, we are writing low signal. That means we are stopping the ultrasonic waves. And pulse in is the function to calculate the duration for the ultrasonic waves after they get reflected from the object. And we are also calculating the distance using this duration variable. And we are returning the distance variable. And in the loop function, we are calling that get distance function, and we are limiting the distance from 0 to 30 centimeter, right? You can see if distance is less than minimum distance, which is 0 defined here, then distance will be min distance. Otherwise, if the distance is greater than max distance, which is 30 centimeter, distance will be set to maximum distance. Now this is the main line of the entire code. So we are mapping the distance from 0 to 30 centimeter to the servo angle 0 to 180 degree. Okay, so object closer means larger angle and vice versa. And we are writing the servo angle on the servo motor, and after a delay of 200 millisecond, we are again calculating the distance, and we are further calculating all the calculations. So if you learned something new from this project, subscribe to my channel and share this video. And if you want me to add something in this project, let me know in the comments. We will meet in the new project. Till then, goodbye.